In this tutorial, you will learn about the while statement. The while statement is a type of repetition statement which allows us to execute a statement multiple times. You will learn the syntax for creating a while statement, and you will learn when to use while statements in your programs. Repetition statements allow us to repeat statements of code over and over. Up until now, your program started, processed statements, and then ended. There are several different types of repetition statements in Java, but for this course we will concentrate on the while loop and the for loop. You will use the while loop when you do not know beforehand how many times the statement or statements will be executed. For example, if you're playing a game with a user, you might want to let the user play the game over and over until they enter a value indicating they are done. The other type of repetition statement is the for loop. You will use this loop when you know exactly how many times the statement or statements will be repeated. The syntax for creating a while loop is the reserved word while followed by a condition which evaluates to true or false enclosed in parentheses. The statement will execute while the condition is true. As soon as the condition evaluates to false, the loop ends. Notice there is not a semicolon after the closed parenthesis. Adding a semicolon will cause the loop to never run, and the flow of control will continue with executing statement. Use a block statement to execute more than one statement within the while loops. Now let's try an example. Starting with the number 2, write a while loop to count and add the number of even numbers needed to reach or exceed the limit of 10. Now that you are getting more comfortable with Java syntax, the problems will increase in difficulty. For problems like these, it's best to plan out your steps using pseudocode. Pseudocode is a cross between English and Java syntax and arrows to indicate the flow of control. The first thing we want to do is to declare a variable to hold the number being tested. We can initialize this to 2 since that's the number we will be starting with. Then we will declare variables to hold the counter and the sum total. Then we will create our while loop. We will loop while the sum is less than or equal to the limit of 10. If the sum is less than 10, we will test to see if the number is even. If it is, we're going to add 1 to the counter and then add that number to sum. We're going to increment number to the next number to be tested, and then we will go up to our condition to test to see if we want to execute that code again. As soon as sum has reached the limit, we will print out our results. So now that we have our logic worked out, we can start transferring our pseudocode into Java syntax. The first thing we will do is create an int variable, num, and assign it the value of 2, the first number to be tested. Then we'll create int variables counter and sum and initialize those to 0. We'll create our while loop. Our condition will test if sum is less than or equal to 10. So while that is true, we will execute the statements within this block statement. We will first test to see if num is an even number. If it is even, we're going to increment the counter. We'll add the number to sum, and then we'll increment num to the next number. We'll execute this while loop while sum is less than or equal to 10. As soon as it's not, we will print out our results. Now I'll show you a skill called tracing your code. You'll become experts at doing this when looking for errors in your repetition statements. So off to the side, I'm going to create columns for each of my variables. So num is initialized with 2 and counter and sum are initialized with 0. While sum is less than or equal to 10. So I'm going to look at the value in my column under sum, and I'm going to compare, is sum less than or equal to 10 true? So I'll hop into the while loop. I'll test to see if num is even, which it is, so I'll add 1 to counter, and then I'll add the contents of num to sum and store it back into sum. So num plus sum is 2, and I'll assign that back into sum. I'll increment num, and then I'll continue back up to my while loop. I'll test again, is sum less than or equal to 10? True. I'll hop into the while loop, and I'll test to see if the contents of num are even. Num currently contains 3, so no, it is not even. That block statement is not executed, and num is incremented to 4. I go back up and test my condition again. Is sum less than or equal to 10? Yes. Is 4 an even number? Yes. So I increment counter, and I'll add sum and num and store it back into sum. So sum plus num is 6, and I'll put the result back into sum. I'll increment num and hop back up to my condition. Sum less than or equal to 10? True. I'll test to see, is 5 even? False. So I'll increment num and I'll hop back up to my condition. Sum less than or equal to 10? True. Is 6 an even number? True. So I'll increment counter and then I'll add sum and num. Sum contains 6, num contains 6. 6 plus 6 is 12, and I'll store the results back into sum. I'll increment num, and when I go back up to my condition, is sum less than or equal to 10? False. Sum now contains 12, which is not less than or equal to 10, so my loop terminates. Flow of control returns to the first statement outside of the loop block, which is the system out println, and I will print out a message. Since counter contained the number 3, 3 was printed, and sum contained the value 12, so 12 was printed. If your condition will never evaluate to false, you will get an infinite loop, meaning that the statements will be executed over and over. So in this example, my condition is to test if sum is not equal to 10. So the values in sum were 0, 2, 6, and then we went to 12. We will never get to 10, and the loop will never end. Occasionally, you may wish to process data input until a certain condition is met. You can specify a special value that signals the end of the input, for example, an N or a -1. So when the user enters this sentinel value, your program knows there are no more values to be entered. Let's write a program to prompt a user for a list of numbers. When the user is finished entering numbers, we want to print a message with the number of numbers they entered and the average. So again, let's start with some pseudocode. First, I'm going to declare variables for a counter and a sum total. While the user has numbers to enter, I want to scan for the number and then add it to the sum. I'm going to increment the counter, and as soon as they are done entering numbers, I will print out the counter and the average. And here is my program. I start the scanner object. I created a variable called counter, which will hold the number of numbers they've entered, and I've declared a double value sum. I'm going to create a string variable called done, and I'm going to initialize it to the value n. I'm going to print a message out to the screen. You have numbers to average. Enter y or n. I'll scan their input into done, and while done equals ignore case y. So if they enter an uppercase y or a lowercase y, this condition will evaluate to true. So while they enter the letter y, I'll print out a message to prompt them for the number. I'll increment the counter, add the number to sum, so I'll ask the scanner to grab the number, which I'm going to use double in case they want to enter decimals, and then I'll print out a message, add another, enter y or n, and then I'll scan that variable into done. So this loop will continue over and over. As soon as they enter really anything besides y, the loop will end and flow of control will return to the if statement. So if the counter is greater than 0, I'm going to print out a message, you entered the value of counter numbers. And then on the next line, I'm going to print the average is, and I'll divide the sum variable by counter to calculate the average. The reason why I test to see if counter is greater than 0, if they never enter any numbers, counter will be 0, and I don't want to get a runtime error by dividing by 0. So if they did enter 0, so if they didn't enter any numbers, I'll print out a message that no numbers were entered. So let's run the program. So do you have numbers to average? Enter y or n, so I'll enter a y. Enter the number, 3.4. Add another, yes. Enter the number, 2.4. Add another, no. You entered 2 numbers and the average is 2.9. So my program works as designed. In this tutorial, you learned that the while statement is a type of repetition statement which allows us to execute a statement or statements multiple times. You learned the syntax for a while statement, and you learned the while statement is the preferred loop when you do not know in advance how many times the statement will be repeated.